We're going to start classifying numbers as natural, whole, integer, rational, or irrational. Some numbers can actually have more than one classification, so we're going to just take a look at that in just a second. We start with the natural numbers. I think in your notes you have this in a little circle diagram, and it's really why they're nestled in like this is because they actually include and can include more than one category of numbers. So for example, the natural numbers and the whole numbers, the only actual digit that separates the natural numbers and the whole numbers is the number 0. So natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. The whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number, let's say 4, for example, is actually a natural number as well as a whole number. Then we move on to the integer numbers. And we use the symbol Z to represent an integer. And that's now going into the negatives. So -1, -2, -3, and so on. And then last, in this particular portion of the number system, is our rationals. And we use Q to represent rationals. And rationals now include negative numbers, whole numbers, natural numbers, but they also now include anything that's a fraction, a terminating decimal, or a repeating decimal. Then we have the irrational numbers, and we write that with a Q and a little line on top. Okay. So when we look at these radical numbers that we've got off to the side, the square root of 16, the cube root of 30, the fourth root of 16 over 81, sometimes it's hard to classify these. So it's always nicer to actually remove the square root or undo the square root. And in this particular case, we're applying the square root. So we know 16 is one of our perfect squares on our perfect square list. The actual square root of 16 is 4. Now, if I look at irrational, rational, integer, whole number, or natural number, I'm trying to go down all the way to the smallest actual number set that this would include. And so this is actually a natural number. Now, you could also say it's a whole number. You could also say it's an integer, it's just +4. And you could also say that it's a rational number because this is technically could be written as a fraction as 4 over 1. It is not an irrational number. And that's why we spent some time classifying the difference between rational and all of its different forms as well as irrational. The cube root of 30, let's take a look at the cube root of 30. And I end up getting 3.107232506, and it keeps going and it keeps going and it keeps going. So in this particular case, this has only got one type of classification. It is a decimal number that does not terminate and does not have any pattern or does not repeat. So this is actually going to be an irrational number. And then we're going to look at the fourth root of 16 over 81. Now we know 16 is a perfect square, and we also know that 81 is a perfect square, but we're not looking for perfect squares. We're looking for fourth roots in this particular case. So when I write this down as a decimal number, I'm going to get 0.66666666, and it's going to go on and on and on forever. If you actually put this into your calculator, you'll notice the last digit is 7, and that's because it's just rounding it up, because it's actually stopping it, but it does go on forever. I think you've also noticed this in your notes that we could write 0.6 repeating with a line on top. This is not a natural number, a whole number, or an integer. It's in fact a rational number because it is a patterned or a repeating decimal.